Today I'm going to be doing a demonstration of a rather custom solution to do music on hold on a 1A2 key system. This here, of course, is a 1A2 key phone. This specifically here is an ITT 2564 set. And these key phones remain instantly recognizable for their classic design and simplicity of operation with hold, line 1, 2, 3, 4, and 5, or sometimes some kind of special function on smaller systems. And even though this technology is considered, as much as I hate to say it, outdated by today's standards, there are a lot of neat things about them. So, for example, the system itself will pretty much just work, albeit in a slightly degraded manner in a power outage. You won't have any lamps or common audible ringing, but you can still make and receive calls because all of the lines are coming into the phone physically through that thick cable there. So there's no electronics needed to select a line or anything like that. So as long as you have a separate ringer on each line, it effectively functions just like a multi-line analog POTS phone. Now, I have my system not wired for common audible. I keep the ringing separate, and that allows me to have things like distinctive ring, and also personally, I just find common audible ringing to be a bit overwhelming. I have a lot of key phones all over the place. In fact, I have two here right next to each other. And so, if I had common audible, that would wake the dead when the phone rang. Now, the key system itself that I have is a Western Electric 551B shoebox. And they are called shoeboxes because they are roughly the size and shape of a shoebox. And these are fairly compact as these things go. This really is the whole system here. So I've now gone ahead and opened up this shoebox, and this is what we see inside. Nothing too crazy. Here on the left we have a 66 block where all of the wires are punched down, and we have all of the cables leaving the key system itself. We have this little guy here, which has the actual trunks that appear on each of the 4 lines. We have the actual runs themselves exiting. We have 4 runs in this case, and then we have power entering through this little thing here, and then coming into the KSU. Now this here is the ring generator, which would be used for common audible ringing. You can see that this is designed to kind of go in the middle here. I have it disconnected because, again, I'm not using common audible ringing, but if you were to use that, then you would want that hooked up. And then here we have the KTU cards themselves. In this case, there are 4 KTU cards, 3 400E cards, and then a 400D card. So there's 4 places where you can put KTU cards into the KSU. And that is important here, because typically the way that you would install music on hold in a 1A2 key system is through a special music on hold card that would go in one of these slots. And as you might be able to guess, the obvious downside of that is that with this kind of compact unit where you only have 4 slots, if you were to do that, then you lose one of your lines. This is a 4-line system. If I were to put in a music on hold card, it would now be a 3-line system. That is a pretty big limitation there. Now, I got to thinking, all of the lines on my 1A2 key system are also connected to FXO ports on my Asterisk system, ports 1 through 4 right here. And that got me thinking that if only I knew when a line was on hold on the 1A2 system, I could just have Asterisk go out on that FXO port and provide music on hold that way. Now that begs the question, how to know when a line is on hold? And of course, that information is all there on the 25 pair runs leaving the system. You just need the appropriate circuit to decode that. And that is where this little guy here comes into play. This appliance here is a 182 interface module. This is an appliance designed by Telos, and its actual intended application is mainly for broadcast applications. So typically a radio station would have these and use these to interface their 182 key system phones with the actual transmitter using hybrids and stuff like that. And of course, I'm not running a radio station here, but one of the capabilities of this appliance is it has a serial port that you can use to receive different events from the 182 system. So here we are in the back of the rack here where this is installed. So there are some phone jacks on here that I'm not using. Those are intended for the hybrid and stuff like that. The only connections in are power. I have this serial connection right there. And then there is a 25 pair cable there that is connected to the 182 system using a CPC device. The only thing I want to call out here is that the 25 pair Amphenol connection on the back of this unit is actually upside down. And what I mean by that is, so this is the cable that's actually going into that unit. And normal 25 pair cables are kind of oriented like this at 90 degrees, right? Now, on this particular unit, that connector is way in the corner there, so it's very close to that left wall of the rack here. And the way that they have it mounted is that this would need to go in with this orientation, which of course is impossible because the wall would be right here, and there's no room for this cable to actually snake around. If they were actually thinking about this, which clearly they did not, they would have oriented so that the cable would go the other way and be able to snake out this way past the rest of the appliance rather than hitting a wall there. So I don't know how they intended that to be used. And because they have this goof in the design, I actually have a 180 degree adapter here. So one of these T adapters that can go in at an perpendicular to the unit and come out here so that I can actually connect it back. So now we can go ahead and actually do a demonstration here. As I said earlier, I have 4 lines on this 182 system. Line 1 is the POTS line. Line 2 is a line on this 8 at 600 channel bank. Line 3 is on a 24-port analog card that is actually installed in this machine. And then line 4 is on this 24-port Grandstream SIP gateway. So here we have the Asterisk console, and I've actually written a module to interface with the Telos appliance, so we can run a CLI command to query the status of the 182 lines. We can see that they're all on hook. Of course, if I were to go off hook on one of these lines, we can see I'm now off hook on line 1, and I can just cycle through each of the lines. Lines 2 and 3 are actually on the Asterisk system, so that's why we see that. Alright, so I'm going to hang up, and I'm going to go to line 2, and we're going to make a test call here from this IP phone. Alright, so call is ringing in. There's actually no ringer on this line. So, hello? So, we're having a conversation, and I've gotten called away for whatever reason, right? And I need to put the line on hold, so we're going to do that. Now you may be able to hear the music on hold. It actually works better for muted. Alright, so now I'm going to go and unhold. Now, you may have noticed something interesting just there. When we were on hold, the music on hold was not terribly loud. It was audible, but it wasn't anything to write home about in terms of volume, right? But towards the very end, as soon as I took that line off of hold, there was about a second or so where it was quite loud. And if you think about the way this is set up, it may make more sense, right? When the 182 system puts the line on hold, there is an added resistance on the line to keep it from hanging up. I'm not actually sure off the top of my head what the resistance is. But there's enough resistance that the volume on the line itself is not very loud. It was not intended for this application where I'm injecting audio into it while the 1A2 system is on hold. So this is kind of outside of what the system was designed for, and that's why it doesn't work as seamlessly as we would hope. Of course, as soon as I take the line off hold, then we hear it loud and clear. And that's because in Asterisk I have bumped the gains of the music on hold. I think it's bumped up about 9 dB right now to make it actually audible, because otherwise it would be super quiet. All right, so now we're going to do a test with line 4. So I'll go ahead and actually I'll make the outgoing call from here. All right, and I can answer. All right, so we are now in a call on line 4. I can put it on hold. And there we go. This one sounds a little bit louder. It also has some static in it. You can hear it clearly. Now we'll take it off hold. And there you heard it again. This one, it was decently loud. I do have the volume turned all the way up, so it may not normally be this loud, but you can clearly hear that it gets louder at the end there. And again, that's because the gains are bumped up, so at the very end, when it's off of hold, there's a brief delay between when we actually go off hold and the 1A2 event for that comes into the system and we drop the FXO. So for that brief period of time, it's a little bit loud, which is why you need to be a little bit careful and not make it too loud, or you could blow somebody's eardrums out when you take it off hold. Not literally, but it would be very annoying. So, all right, so that was, we did line 2, we did line 4. Now I want to show you something interesting with line 3 that happens. I'm going to hang this up, and let's go ahead and make another call here. All right. So this one is also ringing, and you can actually hear the audible ring here as well. For those of you who are wondering, this is not a recording, by the way. That is the actual power ring from the analog card. So that is coming live from the inside of the computer, basically. That is the sound. It happens to sound kind of like CDO ring, some kind of CDO ring or step-by-step ring, but that's actually the power ring. It just happens to sound like that. It only works with the bigger analog cards. The smaller ones don't seem to do that. Anyways, we're on line 3 now, and watch what happens when I go on hold. Nothing. We don't hear anything until, watch what happens when I take it off hold. Alright, so what was that all about? We didn't hear any music on hold while the line itself was actually on hold, but as soon as I went off hold, then we heard it loud and clear, just like on the other lines. And remember I said that each of these lines is on a different type of equipment. Line 3 happens to be on that 24-port analog card. So there's something different about the FXS characteristics of that card itself, such that we don't hear any music on hold. Now I suspect it's because the resistance is so high that there's no audio passing, or maybe it has something to do with the capacitance. I'm not entirely sure, but there is something that is different, such that audio will not pass when that particular line is on hold. It's not the FXO ports, because the FXO ports for all of these that are connected with the 1A2 are also on the analog card. And since it works fine on all of the other 3 lines, I didn't demo it, but it works fine on the POTS line too, the only variable there is the type of FXS connection. So something about the FXS module on the analog card is blocking audio. But again, remember, they weren't intended for this kind of use case where you're passing audio when the line is on hold with that much resistance, so I'm operating kind of outside the specification here. But for cases where it does work, it actually works decently enough. Now here you can more clearly hear some of the static on the line, and this I don't actually mind. It gives it kind of a nice analog effect, if you know what I mean there. But really, this is not supposed to work at all, or at least not by design. It's just kind of a hack job that it works at all. But it is a nice hack. So if you want to create a project and add music on hold to your system this way, it's actually pretty easy. You just might want to verify that it will work with the equipment that you're using. Again, works fine with this channel bank. It works fine with this Grainstream gateway, and it probably works fine with most other things. But you may want to actually do some testing and see if it'll work with whatever you're going to be using as your phone line.